Hello, everyone, and welcome to another session of our Day One and Beyond series where we take you through various topics and activities related to building out on Oracle Cloud. Our session today will cover tenancy and OS security, the solutions that are available today, some advantages that you have when using these services, and how easy it is to get started. I'd like to introduce Vinay and Vishak as our main presenters today. And now I'll hand it over to Vinay to begin today's session. Thank you.
Thank you very much. Hi, everyone. My name is Vinay Kalra. I'm part of the North American Cloud Engineering team. I specialize in identity and access management and also everything security when it comes to the OCI platform. Welcome.
Hey everyone, this is Vishak Chittuvalapal joining, and I'm a CCSP and Oracle certified professional. I'm also part of the same team as Vinay, where we help customers build strong security foundations in OCI across multiple layers, which could be identity, monitoring, secure operations, and operating system layers. So today I'll begin with the tenancy and OS security section. So I'll start with the tenancy and OS security section, where we look at constructs to secure your operating system, starting with OS Management Hub for Oracle Linux and Windows system. And secondly, we will look at how to secure your images or registry with container image scanning. And finally, after that, Vinay will continue with CloudGuard section, covering its significance with respect to posture management, workload protections, and threat detections. So yes, before starting directly on OS Management Hub, you might have been asked this question a lot, and how many of us have been spending hours figuring out which servers are patched or which ones missed updates or which ones are still running old kernels? And I think in the olden times, you would have juggled between multiple tools or run ad hoc scripts to somehow figure this out, right? But the modern approaches require everything out of the box, lesser manual effort, and also offer operating system patching capability, right? And that's exactly the real challenge here, which Oracle wants to solve with OS Management Hub. So with that, in short, the OS Management Hub is a tool to manage our entire OS fleet for monitoring and patching updates. And we are fulfilling this goal to make OS management simpler, consistent, and secure for operating systems across OCI, on-prem, or any other cloud. So let's begin. The OS Management Hub is built to handle environments at scale. So whether it's Oracle Linux or Microsoft Windows servers. I guess the real value here is visibility and control from one console. And instead of different teams managing patches in silos, you get a unified view of your OS fleet. And this not only reduces admin overhead, but also helps you avoid patch delays, which are often the root cause of security incidents. Another key point, it's delivered as an OCI service, but it's not limited to OCI. You can manage instances running in AWS, Azure, or even in your data center. And that's important because we understand that most customers today are hybrid or multi-cloud. And one of the strengths of OS Management Hub is that it supports a mix of platforms. See, on the Linux side, you can manage Oracle Linux from version 6 up through 9 on Oracle Cloud, and third-party cloud and on-prem having an exception for Oracle Linux 6 releases. And for Windows, it supports Windows Server 16, 2016, 19, and 22 across both standard and data center editions in the OCI. So whether your environment is all Linux, all Windows, or a mix, OS Management Hub can cover it from a single place. We will look at the architecture of OS Management Hub. And here the architecture uses an agent for managing and applying updates on an instance. The agent interacts with the OS content on an instance as directed by OS Management Hub and reports data and results back to the service. So now the agent differs between OCI and on-prem or third-party cloud. OCI instances on the left use the Oracle Cloud Agent to interact with OS Management Hub. You enable the OS Management Hub plugin for Oracle Cloud Agent to register with the service. On the right, on-premises or third-party cloud instances require a management station to act as a network proxy to communicate with the service and also act like a local YAM and DNF mirror of Oracle Linux repositories or sources. See, only the management station directly communicates with OS Management Hub, which pretty much eliminates the need for your managed instances to directly connect with OCI. Instances in your data center send and receive all request and response for OS Management Hub through these management station. And when instances have a job to update packages or OS content, they receive the content locally from management station, which overall reduces the amount of bandwidth used for managing instances. Now, OS Management Hub gives you a modern overview dashboard where you can see how many security and bug fixes are pending and whether all your managed instances are actively communicating within the service. So it also provides real-time compliance reports. You can drill down into security advisories, see exactly what's missing, and then apply updates immediately or schedule them for later, all directly from this console. And if you ever want to share these results, you can just download the formats or reports in a format that works for you. And whether it's for sending or sending to a team, rather sharing to a team, or whether it's for an audit, the results are there for you to tap in. So how does OS Management Hub simplify and automate updates across distributed environments? And there are different ways you can manage instances at the individual level. You can see instance details, check and apply updates, install or remove packages. And for Oracle Linux 8 and 9, you can even manage modules. You can also schedule update jobs to run only once or on a recurring basis. You also have the option to manage instances as groups, and groups let you align OS content across multiple servers and apply updates in bulk. And this is really useful for keeping environments consistent at scale. For example, you would like to ensure all production servers are on the same patch level. Now let's dig into management of Oracle Linux instances using OS Management Hub. And let's look at some of the key features in OS Management Hub. The first one is flexibility. You get a lot of control over how updates are managed for Oracle Linux. And a big part of that comes through software sources, which are basically repositories of packages that your servers use for updates. And there are three types here. Vendor sources these are Oracle provide repos with standard content. And there is custom sources, which is your own curated set of packages created from the vendor source. And finally, version custom sources. These are immutable snapshots of curated content designed for managing updates across dev, test, and prod environments. See, the key difference is that a normal custom source can be updated anytime, but a version source is locked once created. So it guarantees consistency across lifecycle environments. And these sources can be linked to any individual servers, group of servers, or a lifecycle stages that you define. See, although there are several ways to manage instances in OS Management Hub, let's start by looking at the individual instance level. Here you get full visibility. Again, you can see instance details, check and apply updates, and run or even run compliance reports to know exactly how many security fixes are still pending. And for Oracle Linux 8 and 9, you get module management. And this UI makes this really straightforward. And for each instance, you will see the total number of available updates broken down to security and bug fixes. You can drill into details of an advisory if you want to know more context or search for a specific update. And when you're ready, you can really create an update job. You can either run it immediately or schedule it for a specific time. And this specific way, you can apply updates in a controlled and predictable way without any surprises. And similar to support for Linux, OS Management Hub also supports Windows instances. Again, at the individual server level, you get the same kind of control as with Linux. You can see the instance details, view both available and already installed updates, and get extra context like KB articles and whether a reboot is required. You can also schedule updates or apply them directly here, just like you do with Linux. And the key benefit here with OS Management Hub, whether it's Linux or Windows, you don't need separate tools. Everything is managed consistently with one single OS Management Hub. So with that, we can quickly dive into a demo and walk you down the OS Management console. So let's start at the landing page. The first question every admin asks is, what's the current health of my VMs with respect to updates? And that's exactly what this dashboard answers for us. So you can look at these three rings in the middle. The first one tells me about pending security updates. And in this case, 3 out of my 5 instances need security patches. The second is for bug updates. Again, 3 out of my 5 has pending fixes. And the last one shows instance activity. So you can notice 2 out of 5 aren't communicating. So if I'm an admin, I'm looking at the red flag here, which I could jump on right away. On the right, you could get quick access to documentation, super useful if a new admin joins and needs to ramp up quickly on OS Management Hub. And at the bottom, OS Management Hub lets me take action immediately. I can add vendor sources, create a management station for non-OCI instances, or create a profile to standardize my setup for new instance that comes in. And the first thing that you would like to do here is to register VMs to OS Management Hub. And generally, the registration of VMs or servers to OS Management Hub varies based on the state they are in, whether they are running or new instances, and of course, where they live, whether they are in OCI or outside OCI. So there's a quite bit of configuration when the servers are on third party or on-prem because it requires management stations and network connectivity setup. But in the interest of time, we will consider an already existing compute instance in OCI to be registered with OS Management Hub. For that, we will switch to compute and then instances. For those of you who are new to Oracle Cloud, computes are basically our virtual machines. We'll select an existing compute instance here. And just for your information, existing compute instances needs to have Oracle Cloud Agent 1.4 or later installed to register with OS Management Hub. And generally, all the newer compute instance will be running with 1.4 or above. But in this case, let's click on Management, scroll down to Oracle Cloud Agent, and look for OS Management Hub Agent and hit the 3 dots and click Enable. You can select the profile, and the profile is basically a registration within OS Management Hub. And I will quickly select a profile which pops up in my window. This and I will quickly set the profile here. So you could see the status now from getting stopped. It will start to be running in few seconds. So this pretty much completes the registration of instance to OS Management Hub. And we will now go back to check and verify the registration OS Management Hub page. And from the instances page from OS Management Hub, you would see that instance got registered successfully and getting monitored for updates in OS Management Hub. Let's head back to the overview dashboard. Let's drill down into security updates report. This is exactly where where I can see my instances needs security patches. At the top, I can see the context of the report, when it was generated, and the scope. In this case, it's for my compartment. And below each row represents an instance. I can see if it's up to date, how many advisories or updates are still pending, the OS version, as well as where it's running. For example, I've got these 3 instances which are flagged red. One on Oracle Linux 9 with 7 advisories, another one on Oracle Linux 9 again with 14 advisories, and finally one on Oracle Linux 8 with 43 advisories. And that immediately tells me where the risks are. I also have the option to download the report. Super useful if you need to share it with your security teams or auditors. But in this case, we will open up a new one of the instance here. We will click on the details page, and you can see every advisory is listed with an ID, short description of what it addresses. And notice many of these are kernel security patches. So these aren't optional, they're critical. And this makes it very easy for an admin, instead of hunting through logs or yum history, I've got a single view of all missing patches per instance. You can click on each advisory, which will give more description about them, and the CV is listed for it and some useful references. But let's dive more on any of the instance for now. And this is where all the magic happens. It shows me everything that needs attention. For example, this instance has 375 available updates, including 209 security patches and 166 bug fixes. Now let's drill into the available updates. At the top, you get a snapshot of these updates, including kernel security patches and bug fixes. I can also see the last check-in time for this instance, which is super useful for tracking recent activity. You can you can either select individual packages that you want to update from the list of available updates in the below screen. But I will apply I'll apply all the updates in one single go with a create update job. So what this job essentially will do is it will take care of everything, ensuring no critical patches are left behind. I can apply them immediately or schedule updates based on the frequency I would like to set. I can also enable automatic retries in case if something fails, and that way I'm covered even if there is a temporary issue during the update process. So in this case, I'll run the updates immediately, and you will see a job is getting created. Below the update section, we also have sections for packages, and these are packages that are installed on this instance. We can search for a package name like Python, and we can see a list of Python related packages. So this is super easy and useful to know your packages. Here, if you want to remove any of the packages for this instance, you can either select individual or multiple to remove. Secondly, it comes with available packages, which are packages available for you to install. And now let's say if I want to install a new version of a package, I would select it from the available packages list, and I would pretty much hit install. Again, the search bar becomes handy to look for what packages you would like to install for this specific instance. Now, in this case, I will select for a specific package and install. So this job is again created, and this pretty much installs the package in that system. Next, if we scroll down, we will also see something called module section. And modules are essentially collections of RPM packages grouped together in Oracle Linux 8 and above. And each module can have multiple streams, which represents different versions of a software stack. For example, here we have modules for Perl, PHP, Python, and toolsets like GCC and LLVMs. The status column shows whether a module stream is enabled. You can choose profiles that install specific versions tailored to your needs. And we can look at what software sources are, and software sources again are repositories where our packages come from. And in this view, we can select one or more sources to attach or detach. So here I would select a specific package if I want to detach, right? And the same case applies for attaching. So if I hit attach, I would see a job name, and then I would select a specific software sources from this compartment. So I'm going to select few of the software sources and then click on apply or click on attach. So what generally means is that this particular sources gets attached to the instance. So in short, this page is about controlling where the instance pulls its software packages from. So while we were talking on the software sources, let's understand this in some detail. On a specific compartment, I can see a list of software sources available on this compartment. You can select a filter from several different types, and I can choose to keep all to view in this case. So now if you remember from the slides, the vendor software sources are added or are added software sources provided by vendor or Oracle in this case for you to use in your instances from its respective compartments. And next there is custom sources, which are again, curated vendor contents from vendor sources. So remember on the slides, there is a version custom source as well from the available type. So when you add a new version here, what it means, it becomes a version custom source, and these specifically are become available to you in a DTAP sort of model, which means you can apply updates of instances for your dev, test, acceptance, and production instances. So generally managing updates across life cycles. The only caveat here is that, as I mentioned, these are immutable. It cannot be edited once software sources are selected and created. But in this exercise, I am going to create a custom source. So you would hit the actions button, click on create custom source, provide a generic name here. Version is optional. I'm not providing the version here. Skipping that to create a custom source, not the version custom source. You can selectively hit the radio buttons if you would like to automatically resolve packages and dependencies. You can choose the vendor version in the next tab. So I'm choosing Oracle here and some OS version and then architecture. So it should be consistent, and you will see the available software sources that comes up in this compartment. You can selectively pick few of the software sources to attach, and then and this particular screen shows you if you want to exclude and include certain packages from the software sources and only include latest versions. So I'm going to skip this and hit next. I'll do a quick review and click on submit. So once a job is created, you will see a custom source which got created and it will show up here. And next useful concept in OS Management Hub is groups. So what if I don't want to look at each server one by one to apply updates or monitor and manage them individually? And that's where groups come in. And groups allows me to logically organize my instance. For example, I might have a group for production web servers, another for test systems. And if I apply a security patch policy to a group, every instance in that group follows the same rules. This means consistent updates, less chance of drift between environments, and a lot less manual effort. So here we are looking at some existing groups, and each group is tied to an OS version and architecture, which ensures consistency across the instances that they belong to it. I'll do a simple walkthrough of how a group can be created in a few clicks. So first I'll hit the create button. And I will choose specific details, and these details could be any specific details of which location these instances come from. These are OCI or non-OCI. I'll select the vendor in the next tab and provide so we can have Oracle or Microsoft in this OS vendor while creating groups. So I'm going to choose Oracle for now and create a Linux group. So Linux 9 group is what I want to create. I'll select a few custom sources to attach. I'll choose the one which got created previously in our previous section, and I'll choose the available instance for this in this compartment to attach. So these two instances align with the same consistent OS versions, vendor, and architecture, and that's why it comes up here. So once I review it, I can click on submit. A group is created. So with this simple, with these simple steps, a group is created. So that's a quick look at what OS management can do, which is structured, consistent, and secure OS management made simple. Now I'll pause here before we move to the next section, which is container security. So now that we have looked at managing operating systems with OS Management Hub, we will switch quick gears and look at how OCI helps secure containers. See, OCI includes a fully managed container registry, which makes it easy to store, share, and manage container images like Docker images. It's OCI native, highly available, and scalable service. So developers don't have to worry about managing or scaling the registry infrastructure themselves. You can use it privately, pushing and pulling images internally in your tenancy, or even host like public images for broader access. So with registry taking care of secure, reliable storage, the next big step is to make sure these images inside are actually safe to run. And that's where container image scanning or vulnerability scanning comes into picture. See, the OCR registry, also known as container registry, can be configured to scan images in a repository for vulnerabilities. The scanner checks images against the common vulnerabilities and exposure database, right? You can simply add a scanner to a container repository, and from then on, every new image pushed is automatically scanned. Even if there are new CVEs that are published later, the registry automatically rescans existing images in repositories that are scanning enabled. So you're not just checking this once, it's an ongoing process. And to perform image scanning, the registry uses the OCI vulnerability scanning service. There are two concepts here. Scanner defines how many container images that are scanned when a target is created, and target defines which repositories are scanned. So the workflow is simple. You define a scanner, you define a target pointing to one or more repositories, and the service takes care of scanning those images automatically. And this gives you flexibility. You can decide exactly which repos you want to monitor and how broad and narrow the scanning should be. And here, what's the results look like? The scanner shows you a breakdown of vulnerabilities by severity, which could be critical, high, medium, or low, along with other details. Now, this helps teams prioritize fixes. For example, critical vulnerabilities can be patched immediately before an image is deployed. Again, the key benefit here is visibility. So instead of like blindly pushing images into production, you know exactly what risks exist in each image. And since scanning is integrated natively into OCI, it's very simple to use. You don't have to plug in external tools just to get like a vulnerability report. Now we will see a small demo on container security as well. And so we are right now here in the containers registry page where developers store and manage container images just like Docker image. You can see the summary here, and this could be number of repositories, total images, layers, and how much space we are consuming. These numbers gives us quick visibility into image activity. Now we can pretty much pick a specific image, for example, custom authorizer image, and open its details. You will see a detailed view of scan results for this image. We can see the scan metadata below, when it started, when it completed, and the overall risk level, which in this case is critical. So hitting the three dots will give you more details. So below we can also see the list of identified vulnerabilities with CVE IDs, risk levels, and descriptions for this image. For example, there is a critical vulnerability in SQLite that could lead to a memory corruption issue. So, and several other high severity CVEs or common vulnerability exposures related to libraries like libarchive and libxml2 were detected. See, developers or security admins can click on each CVE link to get more details and recommended fixes, which pretty much helps them to patch them or rebuild the image before it's deployed. Now, how does OCI know what to scan? And that's controlled using targets and scan recipes in vulnerability scanning service. So I'm here at the vulnerability scanning service page. I have an existing target. So I'll select that existing target for now. And the target, if you remember, it defines what to scan. For an instance, it could be all repositories in a compartment or just a specific registry or image. Um, the recipe, the specific recipe defines how deep the scan should go and what types of scan to include, right? So this case, it's a container scan recipe and it's a container scanning we are doing. And here I've selected the root compartment and I've chosen to include the specific repository here, which is explorecalifornia.com repository. So what happens once this is configured, every new image pushed to this repository is automatically scanned. And finally, I'm here on the scanning reports page inside the vulnerability scanning service. And this gives me an overview of all my scanned images, which ones passed, which ones have critical issues, and which needs attention. You can see this particular image repo token validation function, which is marked as critical. See, that's a signal to dig deeper. And when I click into it, OCI shows me detailed scan results, the number of issues, their severity, when they were detected, and where the image lives. You will notice that the scan found 50 issues, out of which 6 are critical. And this is not something we ignore in a production deployment. Now, OCI VSS automatically classifies these findings and links each one to a CVE ID. So I can pretty much understand exactly what's going wrong. Now here's the detailed vulnerability list, and each entry corresponds to a known security issue. Like this one is a libexpat issue that could lead to an integer overflow. See, OCI provides, or OCI Vulnerability Scanning Service, or VSS, provides full context, the description, timestamp for when the issue was first and last detected. And you don't have to guess this. Each CV links out to our national vulnerability database for deeper insights, which is tightly integrated with this service. Now, if we switch to the cause and remediation for this image scan, expat is the library of package that needs immediate attention. And the recommended remediation is pretty much clear. You have to rebuild your image with the latest base packages, or patch these dependencies, or push a new version back to this registry. So remediation is not optional here. OCI will continue to flag this flag this image until a clean and patched build is pushed. Only once the new image is published, VSS will automatically rescan it and update the risk level. And that's like a continuous assurance, not just a one-time check. So this flow, detect, review, and rebuild, will ensure that only secure, compliant container images get deployed to your end systems. So that concludes my demo on container security. I will now hand it over to Vinay, who will take us through the next layer of tenancy security constructs with CloudGuard. Over to you, Vinay.
Thank you, Vishak. So just a quick brief here. So CloudGuard is our CSPM native posture management service. And today I'll be giving an overview of CloudGuard, and then I will be getting into talking about workload protection, which is our instance security module, and then we'll get into threat detection. So what is CloudGuard? At its core, CloudGuard is a service that scans your environment and looks for misconfigurations or also high risk activities. And it uses the CIS benchmarks, or the Computer Center for Internet Security, and OCI best practices as controls. CloudGuard also integrates with another native service called OCI Event Service. Now, this service is basically what it sounds like. It has the ability to handle any events coming from anywhere within OCI. And CloudGuard does send events when an issue arises. This gives you the ability to trap those events and to be able to connect to external tools. And of course, CloudGuard has a centralized dashboard to give you that bird's eye view of exactly what's happening in your environment. Now, before we get into details, let's cover some terminology. Targets. Target is basically an OCI compartment, and this is a logical construct where your resources are placed. When CloudGuard does a scan, it looks at your target and it uses detectors to figure out whether something is a misconfiguration or whether something is a high risk. If it finds something, it creates a problem ticket. And this problem ticket gives you the ability to take a look and see what the resource is, what the issues are, why the problem ticket actually surfaced. And then you will have the ability to respond to that. So you can respond to it either an automatic response or some sort of manual remediation process. So let's take a look at the life cycle. So as I mentioned on the left, you've got targets. And in this particular use case, the CloudGuard service finds a bucket that happens to be public. This is a rule that's defined in a detector recipe, and this detector recipe is applied to the target. So when it finds this particular bucket, it creates a problem ticket, which happens to be critical. And when that happens, CloudGuard responds by creating a cloud event. And again, you can see here that the cloud event will be trapped by OCI event service. And you can do a simple use case where it's just sending an email to a group of people. There are some built-in services that we can call, or you can do a more complex use case by calling a function. And then CloudGuard will then remediate the problem by changing the visibility of the bucket. So let's take a look at the flow. So again, CloudGuard is scanning your environment. It sees, for this particular use case, that a bucket happens to be public. It finds the issue and it says, okay, well, I did find something, and now let me go ahead and mark it and create a problem ticket for you. And as soon as this happens, the responder kicks in and it asks two questions again. One is, do I have cloud event turned on? And if so, send it to OCI events, which needs to be configured for receiving this event. And then it also asks the question whether you want me to remediate the issue automatically. And if so, then CloudGuard as a service will check to see whether it has the capability to remediate the problem. And then the responder will kick in, and the responder will actually change the bucket's visibility from public to private. All right, so let's talk a little bit about detectors. That example I just gave you, the bucket is public, is an example of a what we call configuration detector recipe. So it'll have, based on the Center for Internet Controls, a lot of different rules that will help secure your environment along with Oracle best practices. An example of an activity detector recipe is something like a user logs in and does not provide multi-factor authentication. That's an example of an activity. Now, CloudGuard has a handful of these detector recipes, but one thing they have in common is that there's two types. There's the Oracle managed. You can think of Oracle managed being the out-of-the-box recipes that come when you first enable CloudGuard. And then you have user managed. User managed is basically clones of either Oracle managed recipes, or you can even clone an existing user managed recipe. Now, the reason why we do this is because we want the ability to change some attributes of the rule in the detector recipe. You can enable or disable a rule. You can, for example, change its input parameters. You can change the risk level. And this is done to fine tune the environment so that you can reduce the noise and you can reduce the fact that you get false positives. Responders also behave in the same way in terms of you're able to clone the responder, but they actually are different than detectors. Responders apply an action to a problem, and there's two types, and we've touched upon it in my use case. One is the notification type, which is a cloud event. And then there's a handful of remediation types that allow you to either manually or automatically make a change to a misconfiguration. So now that we covered detectors, we looked at responders, let's take a look at the life cycle of a problem. So CloudGuard, it does a scan against your target and it finds an issue. And then you have three choices, right? The first choice is you can dismiss it. Dismiss it means that you're accepting the risk. And if CloudGuard does a scan again, it will notify you in a certain way. The second choice is, resolve. You're telling CloudGuard that I've got an administrator that went into the system and resolved the problem. And in this case, let's say that you didn't change the bucket automatically. The actual administrator went in and changed the visibility. Now, if CloudGuard does another scan and it finds that it actually still was not resolved, it will again notify you depending upon the detector type. And then last, we have remediate. This actually fixes the problem. because there's a built-in remediation step in the responder itself. So it will actually make the change for you. Now, CloudGuard is becoming the go-to source of everything security in OCI. So we talked about an example of a configuration. A bucket is public. We have activity detector recipes. I'll be getting into instance security and threat in just a second, but let me just talk about the other things on this slide. So there's also a log insight detector. And basically that allows you to look at the logs in your environment, look for patterns in the logs, and be able to create a problem based on that pattern. So if you're looking for something very specific, you can think of it as almost as customizing your detector recipe and customizing your own rules. The second one is container security. This is different than the container security that Vishak was talking about. This detector recipe deals with Kubernetes containers. And then we have security zones. Security zones you can think of as being a preventative measure. So like in our example, we saw that, the CloudGuard does a scan. It found a bucket that was public. In security zone, in its maximum security policies, it says that you don't have the ability to even create a bucket that is public. So if you tried to create a bucket that was public, you will get an authorization error. Now let's talk a little bit about instance security. So instance security, as I mentioned, is basically our workload protection. It is based on the MITRE ATT&CK framework. It also has the same vulnerability and open port scanning that Vishak talked about on the images. There is a slight overlap, but it also has rules defining those. One nice feature it has is you have the ability to create ad hoc and scheduled queries. This gives you visibility into the compute node itself, things like running processes, file changes, and network to both cloud and on-prem. It also integrates with our logging service. So you can export the logs and you can evaluate what's happening in the logs. And again, you go to the centralized dashboard. So there's a unified security experience here in CloudGuard. So let's talk about the query real quick. So I mentioned ad hoc queries. This example you see here in the left is an example of someone coming in and doing an ad hoc query. And these queries are nice because it's based on OS query, which is a standard. This gives you near real-time view of what's happening to your compute nodes. Okay. And the query language used is very similar to a high-performance relational database. So you can see the select clause, the where clause, etc. And OCI and CloudGuard supports a majority of the OS query tables, along with many of the OCI custom built-in tables. So instance security, we have a compartment, you have your instance there. The way it works is that there's an agent that's installed on all of your compute nodes. And this agent is reading information based on the OS, and it's sending data to the out-of-the-box recipe rules and any scheduled queries that you may have defined. And that generates a report. And if there's an issue, it would generate a problem. We can also send it to logging, as I mentioned, and potentially you can send these logs to a SIM and do more evaluation. The ad hoc query is a query that, like the run query, where you just provide a query based on the OS query tables. And then you can look at the evidence and you can download the data and the evidence and, evaluate whether you see a potential issue. Now let's talk a little bit about threat. Threat detector is a little bit more complex in the sense that there's a lot of information to determine whether something's an actual threat or not. So it is based on machine learning and AI models, and also it's also based on threat intelligent feeds. Again, it's based on the MITRE ATT&CK framework, and it uses correlation, scoring, et cetera, to identify whether something is actual a threat or not. And this is the graphic you see on the right is basically a threat monitoring screen that you get from the threat detector. The threat detector is special because it only has one rule, which is rogue user. And that's the whole basis for this particular UI and what we're looking for in threat detection. So let's take a look at an overview. Threat detection looks at a data source, and this is important. So it's not only getting indicators like IP address, domain, URLs from third-party feeds, but it's also correlating that with our logging system, right? And if it sees a sighting, let's say it sees a sighting of an IP address, it stores that in a resource profile, and then the resource profile stores, you may have more than one sighting. You may have 10 sightings, and the 10 sightings may be coming from different angles, and it's correlated with the logs. So this resource profile gets generated, and then we generate a risk score. And if it's a high enough risk score, well, guess what? Then we're going to create a problem. Now let's get into a quick demo. I can show you all the things that we just talked about. So first we'll go to identity and security, and we'll take a look at the overview page. As you can see here, you get a bird's eye view of your current state of your environment. You have a lot of different widgets here that kind of just give you a good idea of what's happening. At the top, you've got scores. You have your excellent score, which is basically from 0 to 100. And then for risk score, it gives a value from 0 to 10,000. The higher the number, the higher the risk. So relatively, our environment is pretty good, pretty safe. And then we have recommendations that provide you with, usually they give you the high critical rules to fix. Then we have a problem snapshot, and this is nice. It gives you all, what's going on in your current environment. How many critical do you have? In this case, we have 570 plus critical issues. These are clickable. So if you click on it, you go directly to where the problems are. So you can get a holistic view of all your critical issues. We'll come back to this in a second. And then you can also search by different, you can search a problem by different areas and, like compartments. You have resource type, you have detector type. We'll click on resource type, and you can see a lot of our critical out of that 570, 400, and some is coming from BCNs. So this is a different view of your issues. And then some of the widgets below are more informational, location, responder activity, and some trend lines. Now, the next thing we're going to do, that we need to do, is go to recipes. And we are going to look at and see, this is a test environment. So we have a lot of recipes that people have created. We're going to go ahead and find those Oracle managed ones by clicking on the filter. So here you can see we have Oracle Threat, Instance. There are two flavors of instance. One is a paid version, one is a non-paid version. We see container security, configuration, etc. So these come out of the box when you first get CloudGuard. Now to clone them, you click on the clone, and then you can clone from those. Again, you can search for the Oracle managed ones, like you see here. And then also you can clone from clones, and that's why all of these are listed. Now, to save time, I've already created the clone versions, and I put them in a different compartment. So let me go to my compartment, which is a VK compartment. And it cleans up the view here, but these are the different ones I've created. You can see I've created one for threat, instance, and configuration, activity, etc. Let's take a look at one of these. And you can see here that these are the list of rules that have been defined for this particular recipe. A bucket is private is here, but if you can edit this, and if you edit this, we'll see what we can edit. We mentioned about cloning user manage to edit. Here now you can see you can enable or disable it. You can change the risk levels here. We also have this concept of labels you can modify. And then we have this concept of conditional group. So I can say, for this bucket here, for example, it's whether it's in or not in a specific free-form custom list or a managed list. This allows you to tweak it and to include or exclude resources for the scan. And this is part of the whole fine-tuning process. Let's go back up. Now we'll quickly just take a look at the responder. I just made a copy of the responder here, as you can see. And then its set of rules, you'll notice you'll see one cloud event rule. That is a notification. And then the rest of these are remediations. Now let's go and edit one of these. And nothing much to change here except for enable during a disable. But keep in mind, in order for CloudGuard to make any changes, these are the policies that are required. CloudGuard is not going to do this for you unless you explicitly give it permissions. So now that I've created recipes, now we're going to go and create a target. Now I've created a target to save some time here called the VK comp, which is basically my compartment. So let's click on that. And the first screen, you will see I've attached those exact detector recipes to my target. This tells CloudGuard what to scan for. And remember, these could be modified, these could be tuned, so they behave differently based on the compartment you select. Now that I've done that, let's take a look at some problems. So the first one is scanned host has open ports. Let's take a look at that. You got some general information here. And then on the right-hand side, you can see additional information. What was the port that violated the rule? And then we also have something called disallowed ports. This is a list, an input list that you can change to define what ports is considered disallowed ports. If it's in this regular expression, then a problem would surface up and tell you that you use this port. And one thing to note also on the, let's look at the remediation. On the right-hand side, you can see that the remediate button is actually not highlighted because there's no corresponding remediate rule for this. But I can provide those actions as mark as resolved or dismissed. Both of these are very similar. You can add an optional text string for the reasoning behind it for both the resolve and for the dismiss. Let's go back to problems real quick. And let's look at the example that we gave earlier today. Let's type in bucket to filter. And you can see I've got, you should see a couple of ones here. We'll see bucket is public. You can see that. Again, you have your general information, some additional recommendation, and now you'll notice the remediate button is highlighted because there's a corresponding rule that can allow you to do this automatically. Now, if you haven't done this, you would need to add statements to the policy. So you being the user that's running this will need permissions to be able to create these policies before you can allow CloudGuard to even do that. And also we have an input setting post remediation notification. This is nice because it's not only that you want the event system to know that something was a problem occurred, but also when it was resolved. That's another a hook into third-party integrations as well. So now we talked about a little bit about the recipes for infrastructure. Let's take a look at the queries now from instance detector. I did some queries earlier. I have a bunch of select commands to get some port information. And these are ad hoc queries, right? The idea here is you can download it on the right. The idea is that if you submit a query and you like it and you want to use it in a scheduled query, you can do that. So here you can see I can download it. Now I can go over to, I can save it as a favorite, and I can also save it as a query. This is actually not in the right compartment, so I'm going to change this to root. And now you can see that I say I had something called scheduled Q1. So I created a scheduled query based on an ad hoc query. So normally you create an ad hoc query first, and then if you like it, you can schedule it. And the last thing I want to show you guys is a threat monitoring. This is 30-day snapshot of users that are trying to gain access to the system. You can see there's a table. It talks about a score. Some of these scores are low, so they're probably nothing. And then you have like a sightings. And so these are profiles that get created. And these profiles, help you determine whether something's actual rogue user or not. So that concludes the demo portion. Um, so just to reiterate, what did we learn? We learned about OS Management Hub. OS Management Hub is giving your instances up-to-date OS level support. Also, Vishak went over vulnerabilities for instances. I talked about infrastructure protection, which was, protecting misconfigurations, looking at high risk activities. We also talked about instance security, which is more of the workload protection, whereas Vishak was talking more at the OS level, and we talked about threat detection. Here's some resources for you guys. Um, some of these links here for OS management, there's some good links there to get up to speed. For CloudGuard, there are some links here that you use to fine-tune CloudGuard. It's not just enough to turn on CloudGuard and let it go. You're going to get a lot of false positives, especially when you turn it on for the first time. The idea is to use those conditional statements, is to use those user-managed recipes to be able to modify them so that you don't get the noise. You actually want to make sure that the problems that you're receiving are actual problems. So that concludes my section. I'm going to hand it over to Brandon.
All right. Thank you, Vinay and Vishak. Appreciate the expertise today. So this slide here does a good job of outlining many of the different additional training and certification paths that we have available. Oracle University does offer certification training. We have that linked here. We also have our recorded webinar link for day one and beyond. All right, and our next session will be on November 17th. So in this session, you'll be introduced to securing the Oracle database. So we have the webinar covering that topic and the best practices that go with securing the Oracle database. Awesome. And if you enjoyed this session and would like us to conduct personal training sessions for your organization, feel free to email us here. We have our link, our email address here, personaltrainers _us at oracle.com. If you want us to conduct hands-on labs, we have our newly designed Quick Shot Live Labs program for an expedited hands-on learning experience for your organization. And then we also have the Code Innovate program. So this program, we will co-develop solutions based on a use case that we define with you. So please remember that personal training is an investment we make in our customers to help them grow and develop their skills at no extra cost to them. So with that, thank you for joining today's session and have a wonderful day.